Hi friends, so today we are going to solve the problem from the NCERT example 3.8. Here the given the Wheatstone bridge with 4 resistance, one is 100 ohm, 10 ohm and 60 ohm and 50 ohm. So our target is to find the calculate the current through the galvanometer when you are applying the EMF of 10 volt across the Wheatstone bridge. So to find the current through the galvanometer, first we should check whether it is in balanced condition or not. So P, Q, R, S. P by Q equal to R by S. So if the ratio is satisfied, the current to the galvanometer is going to be 0. But in this case, it's not satisfied because P by Q is going to be 10, R by S is going to be not 10. So my P by Q is not equal to R by S. So there will be some finite amount of current flows through the galvanometer. If this is satisfied, the current to the galvanometer is 0, straight away you can write. But in this case, it's not obeys your balanced Wheatstone bridge condition. So we are going to use Kirchhoff loop rule to solve the problem. So in this problem, we have a cell of EMF 10 volt. So what I am going to do here, A, B, C, D is going to be a point E. Here we have a 3 loops, loop 1, loop 2 and this loop 3. So we can, using these 3 loops, we can form 3 equations. So we can find 3 unknowns. Okay. So first I am going to start with the current is leaving from this 10 volt is going to be I. The current entering here is going to be I1. The current leaving from here is going to be what? I2. Right. So the current entering here will be I1 So the galvanometer current is going to be Ig. So from this magnitude, Ig is subtracted. So the amount of current entering in this 10 ohm, I can simply write I minus I1 minus Ig. So here the current coming through the here is going to be I2. The current coming from here is going to be Ig. These two added together, the amount of current entering through this 50 ohm resistor is going to be I2 plus Ig. So at C, the amount of current entering here is I1 minus Ig. Here I2 plus Ig. So I can simply write this Ig gets cancelled. The amount of current again coming here should be I1 plus I2. This is nothing but your I using Kirchhoff junction rule. So the amount of current leaving from the junction equals amount of current entering the junction. So it's going to be again I1 plus I2 equal to I. So I can simply write using junction rule I equals to I1 plus I2. Okay. So using my Kirchhoff junction rule, we will split the current. Next, using the Kirchhoff loop rule, we are going to find the current through each branch. First, I am going to start with the loop ABDA. First, I am going to start with this loop ABDA. So for loop ABDA. So here the current is same direction of the loop. Okay. So I can simply write as minus of 100 I1. Here the resistance of the galvanometer is given 15 ohm. The current through the galvanometer is going to be Ig. Then the potential drop across the galvanometer I can simply write minus of 15 Ig. Here the current is opposite direction of the loop. So I can simply take it as plus 60 I2 equal to 0. Okay. So this is the loop. This is a potential drop around this closed loop is going to be 0. That's why equal to 0. So if I simply write this equation, I1 100 I1. So I can simply write 20 I1 minus 3 Ig. So it's going to be again plus is going to be minus 12 I2 equal to 0. Okay. So now I'm going to solve for the loop BCDB for this loop. BCDB. So for loop BCDB. Okay, so for this loop, the current across this, the potential of across this, the same direction, going to be minus 10 into I1 minus Ig. So here my current exactly the opposite direction, then the potential of across this 5 ohm resistor. So I can simply write plus 5 into I2 plus Ig. So I into R. Okay. So next the potential of across this galvanometer, I can simply write this is exactly the opposite direction, plus 15 into Ig equal to 0. So now the potential drop across this closed loop is going to be 0. Then I can simply solve this problem. Equation minus 10 I1 minus plus 10 Ig. So plus 5 I2 plus 5 Ig minus 15 plus 15 Ig equal to 0. So first I'm going to start with this 10. So minus 10 I1. So Ig 10, 15, 30. So plus 30 Ig, and then we have I2 5 I2. So plus 5 I2 equal to 0. So divided by 5, I can simply take 2 I1 plus 6 Ig plus I2 equal to 0. So minus that. Okay. So this is my equation 1 and this is my equation 2. So next I am going to solve for the loop ADCEA, for this loop. For loop, I can simply write here for loop AD. So this is my loop, right? ADCEA. So I can simply take it as loop direction and current through this resistance in the same direction. The current is leaving from the positive terminal as well. Okay, simply write 10 minus loop direction, current direction will be the same, right? It's going to be 60 into I2. So here loop direction and current direction are the same. So minus 5 into I2 plus Ig equal to 0. Then I can simply solve this equation. 10 minus 60 I2 minus 5 I2 minus 5 Ig equal to 0. So minus is going to be 10 minus 65 I2 minus 5 Ig equal to 0. Then I can simply write 2 minus 13 I2 minus Ig equal to 0, right? So this is my equation 3. Yeah. So using my equation 1, 2 and 3, we can solve the problem. So equation 3 I can simply write 13 I2 minus plus Ig equals to 2. So instead of writing this is my 3, this is my equation 3. So if I want to find my Ig, I should know my I2. If I know I2, I can calculate my Ig. So we'll try to find my I2 using these two equations. Now listen carefully. To find my I2 here, I just want to neglect this. So if I multiply this equation by 10 and add with this. So first I am going to start with this. This is my equation 1. I can simply write 20 I1 plus 3 Ig minus 12 I2 equal to 0. Okay, this is from equation 1. So my equation 2, I can simply write my equation 2 multiplied by 10, because I just want to remove my I1, because I just want to write my I2 in terms of Ig, then I can find my Ig here. So multiply by 10 and add with this minus sign and this gets cancelled here. This is going to be 63 Ig, and then this is going to be what? 10 minus 12. So minus 2 I2 equal to 0. Therefore my I2 equals to 63 Ig by 2. This is going to be my I2 equals to 31.5 into Ig. This is my equation 4. So this my I2 is going to be 31.5 into Ig. So if you substitute my I2 value here, then I can find my Ig. So I just leave this as an exercise to you. So I just stop at this point. If you like this video, share it with your friends and subscribe to the channel for the more content. We'll meet in the next video. Thanks for watching.